Let's talk about solving systems of equations. All right, well, first off, when you hear the word system of equations, don't freak out. It is nothing more than we have more than one equation. I have a system of them, okay? So when we're solving it, if you don't recall the solution, or if we're solving equations, we're looking for where the xy points they have in common. What is their points of intersection? So the graph I have right here, if you notice, the solution, if you will, is right over here. The solution is 3, negative 4. Okay, so that xy point we could write as 3, negative 4. Okay, so when x is 3, y is negative 4. There are several, now this is, if we're dealing with linear equations, you don't always have to have one. I mean, think about parallel lines, you won't have any solutions. But we also can have more than one solution. If you have something like, when we start talking about parabolas and linear functions, you could have more than one solution, if you will. How do we solve these things? Let me move this over here. Okay. Well, if you remember from algebra, we can solve them using a few different methods. Okay, we do have our elimination method. We'll go over an example in a minute. Substitution, we'll do the same thing. Graphing, well, use your y1 and y2 and graph them and find the point of intersection. I'll remind you about that later. And later we're going to talk about matrices. We're not going to get into it today, but we'll save that for another day. All right, well, elimination. Let's start with that one. So how do we do that? Well, let's take a system of equations. Again, it just means you have more than one. There's two of them. And we want to figure out the xy point. Okay, well, you can notice I have the graph down here, but we're not graphing it. We'll get to that in a minute. All right, well, the first way you're going to do this is, let me pick a different color. Let's try purple. We want to eliminate one of the variables. Okay, if we can get rid of the x, then we can solve for y. Or if we get rid of the y's, then we can solve for x. Randomly pick one. How about we get rid of the y's first? Okay, I'll solve for x. So right now, if I were to add up these columns, I would get a 6x here, I would get a negative 4y, and I would get an 18. So I haven't eliminated a letter. Well, how do you do that? You set it up. I have a 2y, and I have a negative 6y. Well, think about this. If I multiply this by 3, that would give us 6y, and that would give us negative 6y. Add them up, the y goes away. So let's do that. I'm going to take, it doesn't matter which one, you take one of the equations, and in this case I decided we're going to multiply it by 3. So long as we're multiplying both sides of the equation by the same number, we're not changing the value of anything. So that's going to give us a 6x, 6y, and that's an 18. Oh, I'm sorry, not yet. And then we are not going to do anything to the second one because we have what we're looking for now. Now if we add up the columns, we get a 10x. This equals 0. And the other side, what is that, 30. Divide by 10, you get x equals 3. Okay, now, we're not done. We have not solved the system of equations. We know what the x value is. Solving it means we have to have the x and the y value. All right? So let's figure out the y value now. How do we do that? Well, once you know what one of the letters are, or one of the variables, if you will, plug them into one of the originals. It could be either one of them or one of them. They're all the same. So I like to pick the ones with the smallest numbers. So I'll choose this one. And we now know that x is 3. So plug it in. And now if you notice, we have one variable. All we have is a y. We can solve for it. So let's do that. This is going to give us a 6, and if we move it over, that's going to be a minus 6 and a minus 6, right? And that equals 0. And then you get 2y equals 0. Don't forget that 0 divided by anything equals 0. Okay, so y equals 0. Therefore, the point of intersection, or the solution to our system, is 3, 0. Let's talk about substitution now. This is another method of solving for the system of equations. Again, finding the xy point. Where do they intersect? If it exists. It doesn't always exist. All right, well, these are the same, I want to keep it consistent, so we have the same two right here, and what the whole idea here is we want to figure out what either x or y equals, it doesn't matter. Take that value and substitute it into the appropriate letter. So let's start with one of them. Okay, it doesn't matter if you solve for x or y first. I'll randomly solve for y first. Okay, so if I want to get y by itself over here, that's going to give us a 2y equals negative 2x plus 6. You could write that as 6 minus 2x, but I always like to keep it in y equals mx plus b form. Okay, just to, if you ever have to graph it, it's very easy to graph when you have it in that format. Okay. Well, let's see. Now, if I divide everything by 2, we are going to get ourselves, excuse me, y equals negative x plus 3. Now that we know what y equals, we are going to take that and we are going to substitute it in. So let's do that. I now have 4x minus 6 times y equals 12. Well, we now know what y equals. Y equals negative x plus 3. Notice here that we only have one variable. Whenever you have one variable, you can solve for it. So let's do that. This gives us 4x plus 6x, don't forget negative negative, minus 18 equals 12. Always combine your like terms. We have a 10x. I'm going to save time. I'm going to do my plus 18 and plus 18 over here, and that's going to give us 30. And then you divide by 10 on both sides, and you get x equals 3, which we were expecting. Okay, we're using the same functions. We better get the same answer. All right, well, again, we're not done. We have one piece of the puzzle. How do we solve for y? Exactly. We do exactly what we just did with elimination. We're going to take the letter, plug it into either one of these, and get the y value. My suggestion, though, is since we already solved for y right here, use this one. Remember, this and this are the same thing. We just tweaked it a little bit. We just solved for y. So this is probably the easiest one to use. So I have negative x plus 3. What's x? X is 3. Negative 3 plus 3 is 0, and there is our same answer. 3 comma 0 is the intersection point. I had it on the other screen, but I didn't show you. Let's show you right now. Okay. Oh, hey, ho, hey. Let me just move that over there. Okay, we're going to graph it in a minute, but if you did graph these two linear equations, you would see right here that the point of intersection is indeed 3 comma 0. All right, now for graphing. If we're going, regardless of the calculator you're using, every graphing calculator, you need to set y by itself. Okay, so that's our first step. I know most of you have 83s and 84 Ti's. Certainly not the best calculator out there, but those are the steps that we use for that. You do second trace, which brings up your calculated functions, okay, and then you go to number 5 for the intersection point. I'll leave that up there because most people are going to need that. Well, anyway, here are the same two equations that we were dealing with before, okay? So we're going to get y by itself on both of them. So let me pick a color here. Let's try orange. All right, so we're going to move our 2x over, minus 2x over here, and then you get 2y equals negative 2x plus 6. Divide everything by 2, and we've already done this one. This comes out to be y equals negative x plus 3. Don't forget, anything over itself is 1, and then 6 over 2 is 3. Over here, same thing. We want to get y by itself, so we're going to move over any term that does not have a y in it, which gives us negative 6y, negative 4x, plus 12. And then divide everything by a negative 6. And that'll give us y. That reduces to a positive 2/3. And what is that? Negative 2. All right, so there's our two equations now. We have negative x plus 3 and 2/3 x minus 2. Plug them into your y1, your y1 and your y2, and graph them. Please keep in mind that calculator, just never, I always say play it safe. Whenever you're doing a fraction, make sure you put it in parentheses, okay? Don't assume the calculator knows what you mean. All right, so now if we look at this, okay, well, let me Move that one there. Okay. So here's the graph. If we were to graph these two, and if you do your point of intersection, you're going to clearly get this point right here, 3, 0. And if you look at the graph here, first right here we have the y-intercept is 3. There's my y-intercept of 3. We have a slope of -1, which means we go down 1 over 1, down 1 over 1. You connect the dots and you have your line. For the other one, we have a -2, which means our y-intercept is down there. And then we're going up 2 over 3. So I go up 2 over 3, up 2 over 3. Graph your two lines, find the intersection point. Okay, and our answer is the same, 3, 0. Okay, just keep in mind though that now this example we just found, we used had one solution point. Okay, we had two straight lines, and wherever they intersected was our solution point. They don't always work out that way. What if I simplify two examples or two equations, and I get something like this? -3x plus 5 and y equals -3x minus 1. Well, what do you think? What do you notice here? What happens when lines have the same slope? Okay, don't forget y equals mx plus b. Okay, these are your slopes. Well, same slopes, parallel lines. Okay, I might not know what they look like, but I do know it's a -3x, and they're going to look something like this. Okay, if they're parallel lines, and that means they're parallel, how many times do they intersect? 0. Okay, parallel lines have no intersection points. There is no solution. All right, so now we have one solution example here. We have no solutions over here. What about this example? What if I gave you these two equations? What if we have 3x plus 2y equals 7? I'm sorry, make that a 7. And then over here we'll do 6x plus 4y equals 14. All right, well, let's solve for y and see what happens. So I move my 3x over. We get 2y equals -3x plus 7. And then we divide everything by 2, and we're going to get -3/2 x plus 7/2. All right, let's do the same thing over here. We're going to get y by itself, so I'm going to do a -6x on both sides and get -6x plus 14. And divide everything by 4, and we're going to get this. 6 over 4x plus 14 over 4. Well, if you notice, let's simplify these fractions. And they simplify to be the exact same line. Look at that. So what happens in this case? They're the exact same line. Well, graphically, right, if I have a line, well, that's a negative slope. So let's just say there's one line, and then if I graph the next line, let me just change the color to see it. And then I graph the other one right on top of it. Well, actually, that's right on top of it, right? What happens? They're the exact same line. So how many solutions do they have? They have infinitely many solutions. Infinitely many solutions. Okay? Because they share this xy point, this xy point, this xy point, they share every single xy point on the line. Okay? So the answer is infinitely many. All right, we've just discussed 3 ways of solving the same system of equations. Tomorrow we will introduce matrices. Tonight for homework? Well, actually, not tonight. What am I saying? Your homework tonight is to have taken notes on this lesson. Tomorrow when we come into class, we are going to focus on this homework assignment right here. Okay? I say homework assignment, but we'll be doing it in class. Okay? Be ready? See you then.